For the longest time, we thought we knew the main bad guy in stomach cancer. But it turns out there's a whole crew of hidden culprits. This new research gives us a totally new map to understand the disease, and we're going to walk through it.
Okay, let's dive right in. The story of stomach cancer has always had this one single villain. But what if that's not the whole story? What if there have been other accomplices, just kind of hiding out, that we never noticed before?
And that prime suspect? It's always been this one bacterium, Helicobacter pylori, or H. pylori for short. For decades, it's been public enemy number one. We've known it's the biggest risk factor, and pretty much everything we do, from prevention to screening, has been built around finding and fighting this one guy.
But here's where the plot thickens. Researchers started noticing something strange. Stomach cancers in people who don't have H. pylori are actually on the rise. And for a long time, nobody really knew why. That's a huge clue that there has to be something else going on, right?
So to crack this case, a team of researchers decided to go full-on CSI. They treated it like a crime scene investigation. They built this incredible multi-omics atlas. I'm talking everything from genomics and proteomics to environmental factors and the microbiome, basically dusting for every possible fingerprint to find new clues.
And you know what's wild? Their first big break didn't come from looking inside the stomach. Nope. It came from the outside world. They found this totally unexpected environmental clue, and it turned out to be a really big deal.
So let me introduce you to the new villain on the scene, a chemical called dibenz A-RH rhydine, or just DBAC. It belongs to this family of chemicals called polycyclic aromatic hydrocarbons, or PAHs, and these are some nasty characters. You find them anywhere there's incomplete burning, so think tobacco smoke, car exhaust, even that blackened char you get on grilled food. And the impact of this DBAC is, well, it's pretty shocking. Just look at this graph. The patients who had this DBAC signature in their tumors had way worse survival rates. You see how that blue line just plummets? That's not just a line on a chart. That represents a really serious risk.
Yeah, and this chemical isn't just hanging around doing nothing. The study found it's an active player. It's basically an accelerant for cancer. It helps cancer cells invade, it shuts down the immune system so your body can't fight back, and in some tumors, it can crank up the risk of progression by almost 6 times. It's bad news.
Okay, so the investigation now has an environmental culprit. But that wasn't the only new lead. The detectives turned their attention back inside the stomach, to the other microbes living there. And what they found was this whole complex ecosystem, a neighborhood where H. pylori wasn't always the kingpin.
So it turns out the stomach isn't just one big, uniform place. The researchers found it has these distinct microbial neighborhoods. You can see them here in the different color clusters. You've got the one where H. pylori is in charge, which we expected, but then there are others, dominated by different bacteria like Streptococcus or Microvirga, and even a mixed community type.
And right there, in those new neighborhoods, especially in the cancers that didn't have any H. pylori, a new accomplice stepped out of the shadows, a bacterium called Streptococcus aeruginosus.
So how does this new accomplice cause trouble? Well, first you got to understand how the stomach protects itself. The cells in the stomach lining are held together by these things called tight junctions. The best way to think of them is like the mortar between bricks. They're the molecular glue that seals everything up tight and creates a protective wall.
And the evidence against this guy is pretty damning. Check this out. They found that when S. aeruginosus was present, the levels of those molecular glue proteins went way down. So it's basically dissolving the mortar between the bricks, breaking down that protective wall, and leaving the stomach wide open to damage and inflammation.
So let's put it all together. You've got the environmental bad guys, you've got these different microbial accomplices, and suddenly the picture of what's happening in stomach cancer gets a whole lot more detailed. We've got a brand new map. And a really critical piece of this new map is all about location, location, location. I'm talking about the geography inside the stomach. The study found that where a tumor grows literally changes its entire biology. It's not just one disease. Its behavior totally depends on its neighborhood. They even identified 4 distinct anatomical zones, which is way more detailed than just saying upper or lower stomach. And just look at how different they are. If a tumor is in the upper part of the stomach, the cardia, it tends to fire up pathways linked to DNA damage and cell movement. But if it's down in the lower part, the antrum, it's more likely to activate pathways for cell growth and inflammation. Completely different strategies. And that's exactly why this new, detailed map is such a game changer.
Okay, so this is all fascinating science, but here's the billion-dollar question. So what? How does all this help actual patients? Well, this new map isn't just for show. It's literally a roadmap to creating smarter, more targeted treatments.
Let me show you just how big the problem is. In the study, almost half the patients, we're talking 49.2%, had none of the standard biomarkers that doctors look for to choose a targeted therapy. For them, the options were basically just chemotherapy. That's a huge group of people left without better options.
But this research gives us a powerful new tool. Look at this decision tree. It's a much smarter way to predict how a patient will do. It goes way beyond just the stage of the cancer. It asks a series of questions. First, is the patient stage 4? If no, do they have this other signature? If no again, what's their immune profile look like? By adding in all these new clues, it can sort patients by risk way more accurately than before.
And remember that huge group of patients, the 49% with no targeted options? Well, by digging deep into all this new data, the researchers found something incredible. A brand new vulnerability, a chink in the armor, a new potential target for a drug.
It turns out there's a specific pathway called the CDK4 signaling pathway, and it was highly activated in precisely those tumors that were missing all the other biomarkers. And this is a massive deal. Why? Because we already have FDA-approved drugs that target that exact pathway. This could open up a whole new treatment option for all those patients.
So at the end of the day, this research just completely rewrites the book on stomach cancer. We've gone from a simple story with one bad guy to this incredibly complex picture, an ecosystem where the environment, our microbiome, and even the specific real estate inside our own bodies all play a role. And it leaves us with this huge, hopeful question for the future of medicine.